terms that we need to know. Then it gets into finding inverses and graphing them and domains and ranges and a lot of different things here. Today we just want to do the basics of what is an inverse, what has an inverse, and we'll go from there tomorrow. So when we talk about inverses, you're going to hear me talk about one-to-one functions a lot. So a one-to-one function, the actual definition that you'll see says two different inputs in the domain correspond to two different outputs in the range. So we know that if something's a function, then the x never repeated. If it's one-to-one, it's telling us if you have different x values, they have different y values. Another way to think about this is if it's one-to-one, y never repeats. Okay, every x value gives you a unique y value. We never get the same y value out twice. So functions x doesn't repeat, one-to-one, y doesn't repeat. So we'll start just looking at a couple ways functions might be represented and deciding if these things are one-to-one. So let's take a look at this first one. Everybody with me? So this is just a mapping. This would be my domain and my range. Is this going to be a one-to-one function?
No.
Why?
38 repeats.
Yep. What about B?
Yes.
Yes, we look, all of these have a different y value. Shorthand I do 1-1 for one-to-one instead of writing it out in words. You're welcome to do either. So that would be a one-to-one function. All right, so you guys try this one. Take a second on your own, yes or no for each. So what do you think for A?
Yes.
Yes.
Yes, everything had a different y. What about B?
No.
It will just repeat.
All right. So to find if things are one-to-one, we have two different options. There's an algebraic way to look at it, and then there is a graphing way to look at it. The algebraic way is to start out assuming you get the same y value twice. So we'll start out with the assumption f of a equals f of b. And we'll solve that. If we get to the end and we get a equals b, then that means it's one-to-one. If you get anything else, that means it's not. So let's take just that idea, and I want to show you how we would do these algebraically, and then we'll talk about another approach if you don't like that. So to decide if this is one-to-one, one-to-one means y doesn't repeat. So we will start out assuming y does repeat. F of a equals f of b. Okay, f of a just says you go to your function and you replace your x with an a. F of b, if we go to our function, replace our x with a b. Now if I want to solve this for a, get the a by itself, what do? Subtract our 7. And divide by -3, and you get a equals b. So we start out assuming we had the same y value twice, and we found the only way that happens is if we plugged in the same number for x. So that means it is one-to-one. Okay, if I look at b, so f of a equals f of b. F of a, we plug in an a for our x. F of b, we plug in a b for our x. And then what would you do? Square each side to cancel the square root. So 49 minus a squared equals 49 minus b squared. Then what do you do? Divide by -1. When you get rid of a square, what do? And when we add a square root, we also have to do? So we get a equals plus and minus b. So is this 1-to-1?
No.
You can also decide 1-to-1 by looking at a graph. We know that in functions, x didn't repeat, so it had to pass the vertical line test. 1-to-1 is making sure that y doesn't repeat, so it has to pass the horizontal line test. So if I look at these same two, you could grab a graphing calculator or just graph it by hand. -3x plus 7. What's that look like? It's a line, y-intercept 7, slope -3. So it looks like this. Does that pass the horizontal line test?
Yes.
Yes, no matter where you draw the horizontal line, it only hits it one time. So that one's good. Square root of 49 minus x squared. How does that look like?
Isn't it like two? Isn't that the thing where it starts and then it approaches asymptote?
It's actually, if you grab the calculator, it's a semicircle. So, does that pass the horizontal line test? We can see if you put a horizontal line here. It passes the vertical, it's a function, but it is not 1-to-1 because it fails the horizontal line test. Alright. Last one, I want you guys real quick, A and B on the next slide. Decide if these are 1-to-1. So you can do algebraic, you could do the horizontal line test. We know what these graphs look like, so I'm going to assume you would probably do that. Take a second and decide.
Do we have to show the graph?
I mean, for this, I guess not necessarily. On the test, you would want to give me some justification. All right, so what do you think on A? Right, if you look at that, it's parabola, it definitely fails the horizontal line test. So it's not 1-to-1. Okay, what about B? This passes the horizontal line test, so it is 1-to-1.